Number 5, it says find.
Find the intervals of increasing/decreasing in relative extreme function.
My pen disappeared.
But the one you threw,
You threw it
on
onto
the
the
front of your
desk.
desk.
No, that one was a red one. That's weird.
No,
That's Broadway.
Oh, I found it.
Welcome to the
What
video.
Oh, y'all want to put a message?
Yeah.
All right, Hamilton, go. What do you want to say?
Welcome to the video.
That's it?
That's it.
All right. They said thank you. I heard it.
Okay, good.
They're skipping it.
The future them says thank you.
Broadway when Alex
They're just pressing the right arrow. Just like
That was so.
I need him to do that again.
I'm gonna
Yeah,
make
you get stopped.
I haven't seen him this year.
Hey, they're already like 2 minutes in. And
All right, let's go on to our derivative. When you're finding the intervals that are increasing and decreasing, I need to figure out is my f prime negative or positive, and that's going to tell us our original function. So f prime of x. Now this problem is going to take a long time, so no complaining. All right, that's why we're skipping that one other problem. What is the derivative of half of x? 1/2. And I'm going to put that minus sign. What is the derivative of sine of x? Cosine of x. And our derivative will have our relative minimum or maximum at 0. So write all over since we're omitting the second one. So let's go ahead and put on this one. Cosine of x is equal to 1/2. And let's do a quick reminder. Cosine has adjacent over hypotenuse, correct? So let's write out adjacent and hypotenuse. And cosine specifically is an adjacent movement, meaning everything on the right is positive. 1/2 is positive. So what I want you to do is make your quadrant and give me 2 reference triangles on the right side. And that is my x. And this is simply review from pre-cal. So if I lose you at any point, you need to come in for tutoring. But I'm going to explain it fully though. So let's do a recap of pre-cal. So we had 30, 60, 90 degrees. And in radian mode, is someone already complaining? Oh. I heard something else, right? Like, ooh. It's okay. You're going to go somewhere over the weekend. It's a good thing. Pi over 2. We won't say anything, though, since I'm recording. So we have 1, root 3, and 2. All right. Cosine is adjacent over hypotenuse. So my adjacent is 1, and hypotenuse is 2. That makes my opposite radical 3. So when you go back to your ratio, opposite of radical 3 is pi over 3. So that means one of my critical points has to be pi over 3. So let's write critical number, x equals, with a set notation. It doesn't have to be set if you don't want it. And then let's go ahead and put in the ratio on the bottom one. So we know this is 0 pi, and our coterminal of that is 2 pi. And because of our denominator of 3 pi, we like that as 6 pi over 3. And if I know this angle is 1 pi over 3, what is 1 less of 6? 5 pi over 3 is our other critical number. That's a pi. So now let's go to make our number line. On our number line, we typically write out negative infinity to positive infinity, but what's the domain restriction given? The low number must be 0, high number must be 2 pi. But if that's not given, we can automatically put in positive and negative infinity. So we have our smaller critical point is pi over 3, and the bigger one is 5 pi over 3. And let's think about what numbers we want to test. So from, I would say from pi over 3 to 5 pi over 3, testing out a pi would be a clever number. What's that? You could do pi over 2 as well. If you do pi over 2 or 2, you will get the same sign on this one. It doesn't matter, okay? And then on here, I know we can't use 0. So let's use one of our numbers. So we're at pi over 3. What's the number directly next to that is before? Yes, pi over 6. And the number I'm going to use from 2 pi over 3, again, there's many numbers you can use. I think I'm going to use 11 pi over 6. Because 11 pi over 6 is between 5 pi over 3 and 2. So let's start. 1?
Yeah.
We're using 1 pi over here.
No, like just 1.
We want it in pi because we want it in radian. Okay? Okay, let's start testing them. So when I test my pi over 6, and that's going to go back to this form right here. Let's write out 1/2 minus cosine of pi over 6. And as a reminder, I'm going to draw pi over 6 because it's been a while. Is that right? Okay. So we know pi over 6 is 1. Hypotenuse is 2. Adjacent is radical 3. And we know our cosine is adjacent over hypotenuse. So I have 1 over 2 minus all of this is radical 3 over 2. Isn't 1 less than radical 3? So if I give you a small number minus a big number, what's my end result? Is it a positive or negative? Negative. So let's do the same thing with pi, but then for pi, since we have a quadrantal, let's go ahead and label. We know this is 0 pi. Then we know this one has to be 1 pi. And that point is -1 comma 0. So let's write out 1/2 minus cosine of pi. What is the adjacent movement of cosine of pi? So my adjacent movement is -1. So 1/2 minus the -1. Is that a positive or negative? It is a positive. Okay, our last one, let's plug in 11 pi over 6 this time. So we have, for 11 pi over 6, let's make our triangle. It's going to go down here. And here I have, if it's 11 pi over 6, what's our reference angle? Pi over 6. And if you forgot, we know 2 pi is equivalent to 12 pi over 6. And 12 minus 11 is 1 pi over 6. So opposite of pi over 6 is 1. Adjacent is radical 3. And then we know our hypotenuse is 2. Does it matter that 1 should really be negative when we're looking at cosine? That doesn't matter. So let's plug it in. We have 1/2 minus cosine of 11 pi over 6. And we know just of that trig is going to give us minus radical 3 over 2. Is that basically the same one as what we did right above? So we have another negative. So let's do our sketch. The function is going down, it's going up, and it's going down. And let's make our general sketch with our highlighter. And let's notate where the relative minimum and maximum is going to go. Here's our relative maximum. And there's our relative minimum. And let's write out the phrase that we did just like yesterday. So the first thing it's asking us is, where is it increasing and decreasing? So on the bottom, let's write out the function is increasing at the following. Is it going up right here at these two? And write that as a interval notation, pi over 3 to 5 pi over 3. And the reasoning is because f prime is what? Positive. Very good. Can we mimic the same thing with the decreasing portion? Function is decreasing. How many are we going to list out the decreasing part? There's 1 here and union 1 there. So I have 0 to pi over 3 union, and then 5 pi over 3 to 2 pi. And what is our because reason? F prime is negative. And that's the way the AP test wants it. And we'll practice enough. Now let's do the one that's got relative minimum or maximum. So the function has a relative, since the minimum came first, let's list that one. You can list the maximum if you want. What number is the minimum at? X equals what number? Pi over 3. Now, when you're saying because on this one, there is a minimum because initially it went down and went back up. So we have to mention because f prime changes from negative to positive. Here's what I don't want you guys to say. Do not say because it's changing sign. Because when you're changing sign, it could go from positive to negative or negative to positive. The order does matter. All right? Okay, let's mimic that for the relative maximum. The function has a maximum. What is my x value at? 5 pi over 3. And for my because, what sign must come first? Very good. Positive to negative. And when you're physically looking at the graph, it's pretty obvious. So I think the hardest part is like more of a reminder of pre-calc, right? Okay. Let's go on to the next page. Okay, on our next page, how many are we doing? Just 2? All right, so part C is what rule for the derivative? Quotient rule. So in case you forgot, the bottom is whatever that messy value squared. What sign is going to separate the top piece? Minus. So here's our reminder. Derivative of the top is 4 pi cubed. What do I do at the bottom? Keep it. Minus, I keep the top this time. And we derive the bottom, which is how many? 2x. And then from here, we're just going to simplify the top. Now, when I'm simplifying the top, I am going to do 2 things at the same time. We are going to distribute the 2x, but I want to at the same time distribute the negative. So I'm not writing too much. So I have, just by the first set, 4x to the 5th. And then I get minus 2x to the 5th. Is everyone okay with that? And then I get a minus 2x all over x to the 4th. So far, so good? Now let's combine like terms. I can combine these 2. Is that right? So when I do, I get 2x to the power of what? 5. And keep everybody the same. So let's do a quick reminder of critical points. You find your critical numbers on the following. Your numerator must equal 0. And sometimes your denominator, if your variable is on the bottom, must also equal 0, because that's also where it's undefined. And where it's undefined could also be a critical number. So, since I know I have to set the top equal to 0, let's go ahead and factor. What factors out on the top? 2x. And I have remaining x to the 4th minus 1. Let's leave the bottom as it is, because I just want to. And I like parentheses, so why not? So here's our critical numbers. On my denominator, what can the x never equal? It cannot equal 0, so our critical number is, when x equals 0 is undefined. And then I need to figure out when is my top equal to 0 as well. So let's write equal to 0 and equal to 0. And I know I have our 2 individual factors. When I set 2x equals 0, what is my critical number? 2x equals 0 is 0. Didn't I already have that? So do I need to write it again? No. Sometimes it could be the same thing and it's okay. The next piece I want to write out though. When you have x to the power of 4 minus 1 is equal to 0. Here is a given fact. As long as your power, that's a 4, is an even number, treat it like x to the power of 2. Because if I have x squared and I square root it, how many 1s do I get? When you square root something on both sides, don't you get positive or negative 1? Yep. So here's the bottom line. X to the power of any even number, when I do square root or 4th root or 6th root or any of that, it's always going to be plus or minus at all times. So let's fill it in. X equals plus or minus 1. Is everybody writing? Yep. Okay, go ahead and make your number line. On our number line, we have f prime on the bottom, f on the top. Are there any restrictions on our domain? Nope. So negative infinity to positive infinity. We have 3 critical numbers. So the first number in order is -1, 0, and 1. And let's put in some numbers in between to test. What number do you guys want to test before -1? Okay. How about at -1 to 0? -1/2. I'm going to assume half right here. And 2. Okay, when you're testing, you're always going back to the factor form. So let's go ahead and write something. We have 2 sets of parentheses on the bottom and one on the, or top and one on the bottom. And one thing that's going to be mindless. If I take any number to the power of an even number, isn't that always positive? No thought process on that one. Now let's plug in the -2. When I plug in -2 into my 2x, is that positive or negative? Negative. When I plug in the negative into my second portion, what am I going to get? -2 to the power of 4 is 16, minus 1 is going to be positive. So we know our end result is going to be negative. So with the partner, go ahead and plug it in for 0.5, -0.5, and 2. Plug it in.
So it comes out to be, one second. Comes out to be. Sorry, I was like trying to. Wait. Like that's, it's my name. Alright. Alright. So.
This.
All sunshine together.
What happens when you use it?
One. Oh. This is weird.
No, it's because.
I think I want to do one of them to plug in with you guys. How about this number? Do y'all need me to plug in the -0.5 or no? Do? Okay. So on this one, we have something times something over some positive at all times. So we know when I plug in -0.5 into this one, it has to be negative. Is everyone okay with that? For this piece, I'm going to go ahead and rewrite. Are y'all ready? It could be double negative. Yep. When I plug in -0.5, that's really -1/2, right? To the power of 4. -1/2 to the power of 4 is 1/16. 1/16 minus the 1, really you're subtracting 16/16 is still negative. So there we have a positive. So I guess if any, plug in the numbers, testing the point might be the difficult part, right? All right, let's go ahead and do our sketch on this one. So the graph's going down, up, down, and up. And I'm going to draw the arrow since we have infinite on left and the right. Are we okay not writing the statement on this one since we did a whole one on the back?
Absolutely.
All right, let's go to E. On E, what rule are we using? Product. I see X in 2 locations. Write it with the parentheses. So let's do a reminder of the product rule. So the rule says derive the first one. What's the derivative of X? And then we keep the second one. Someone's talking over me. Not cool. And then we keep the first one, X. The derivative of e to the x is that itself and the derivative of the power. So it is this in itself. What is the derivative of my power right now? 1. If you don't want to write the 1, you don't have to. Let's set this equal to 0, and I want to rewrite this without the 1s. So it looks kind of neat. What can I factor out? E to the x. So when I do, I get 1 plus x. And I'm going to put that in parentheses. So I need to go ahead and set this one equal to 0 and this one equal to 0. So I want to talk about the second piece first. Second piece is going to give me x equals how many? -1. So now, when I set e to the x is equal to 0, here is a reminder, and this is even going back to algebra 2. E to the x is an exponential function that looks like this. And when I highlight this function right here, Does it ever go past a 0? Does it ever go to the negative number? Can it ever equal 0? So we know e to the x can never equal 0. So therefore, that's not a critical number. So let's go ahead and make our number line. We have one critical number at -1. Negative infinity and the infinity, f prime and f. What number should we test on the left? Okay, -2. How about the right? 0. Good number. So let's go ahead and test it to this form right here. It's always a factor form to make your life not miserable. So we have two sets of parentheses. So when I plug in -2 to the e to the x, and like I said, e to the x is always what kind of number? Always positive. So I don't even have to plug it in. When I plug in the -2 into 1 plus x, we get a negative. And this will produce a negative answer. So our graph is going down. Now plug in the 0. The first one, again, it's always positive. Plugging in the 0 into the second portion, it's going to give me +1. Again, just positive. So this graph is going to go up. So our derivative or our function graph is going to look like this.